Hey guys, welcome to another Tenfold live show, proudly brought to you by Liberty. Guys, these are really great sponsors. I really thank them for sponsoring the show. We can't do any of this without them. It's my turn this part of the week to take the whole show with you. If it's the first time that you've joined, we're dealing with matric maths. And this week we are currently working with analytical geometry. So guys, if you have any questions on analytical geometry, you are more than welcome to send them through on our Facebook page or our WhatsApp line. With that, let's get started with today's show. We've got a great question from Mapitso. Let's have a look at what she has to ask us.
Analytical geometry, also referred to as Cartesian or coordinate geometry. Analytical geometry uses algebraic methods to represent and solve geometry problems. The correspondence between geometric shapes and algebraic equations means we can convert geometric problems into equivalent algebraic problems and solve using algebraic methods. To be successful at analytical geometry, you will need to understand all of the work done up to grade 11 and, in addition, the concepts of equations of circles, equation of a tangent to a circle, and length of a tangent to a circle. In preparation for your exams, make sure to watch all of the analytical geometry videos and attempt all of the assessment equations at the end of the lessons. Once you have mastered those skills, the career video will take you beyond the classroom. Analytical geometry is roughly 40 plus minus 3 marks in the final exam, which is approximately 27% of Maths Paper 2.
Okay, oops guys, sorry about that. We went to an intro video. No worries. So this video over here, as you can see, it's all about analytical geometry. And if you watch the video very carefully, you can tell that we're going to be busy with a lot of concepts from grade 10 and grade 11. So if you are in grade 10 and grade 11, no worries. You can still watch the show. And this show or this topic is very helpful for you for when you go into grade 12 or grade 11 the following year. Let's have a question now from Mapitso. Let's have a look at what she has to say.
Good day. My name is Mapitso Nalpa and I have a question based on analytical geometry. Here it is. It's question 7. I've been struggling with it for like a week now.
Alright, thanks for that question. I'm going to be honest with you guys. When I first saw this question, I was like, wow, okay, this is a monster of a question. I'm not too sure where to start. But that's going to happen to you when you get into an exam or in a test. So let's have a look at what the question says exactly. It says here that a circle with center O lying on the line y is equal to x divided by 3 plus 1 passed through the points P, which is 3 and 6, and Q, which is 7 and 2. And the first question asks us to determine the equation of this circle. Okay guys. So as you can see from this question over here, we don't actually have a diagram to work off. So what we need to do is we can draw ourselves a little diagram. It doesn't have to be accurate, but it just gives us some reference points that we can work with. And then from there, see what we can do and try and solve this problem. So let's have a look at how we're going to draw this diagram. So the first thing we're going to do is put some axes in for us. I'm going to have these as my axes. And they say that we have some circle that lies on a line. So I'm going to draw my circle. Let's get a circle, change my color. So we're going to have a circle over there. I'm not too sure what it looks like, but that's not really important. What we do want are these 2 points P and Q on the circle. So P is going to lay around about there. That's going to be P, which is 3 and 6. And then we're going to have Q, which is going to lay somewhere over there. That's going to be Q, 7 and 2. Okay, now we've also got this line that passes through the center of the circle. So let's put that line in for us quickly. So it goes through, if you can see over here, it goes through 1 and it's going to have some gradient over there. And that's going to be my little circle that I've drawn for us. And we've got some center, which we're not sure of the coordinates, and we're going to donate them by A and B. Okay. Okay guys, so what we have over here, we've got our little diagram over here. It's not accurate, but it does help us just to try and see where we can go. So the first thing that we're going to try and do is now try and find, well, how can we look at this circle and see, well, what do we have to try and find the equation? Well, firstly, we're going to have that our radii of a circle from the center to the circumference is going to be equal. And that's going to help us because we can use this fact when we solve for the equation. So our first part, what we're going to do is we're going to write down the generic equation for a circle. And that's going to be x minus a squared plus y minus b squared is equal to r squared. Now, we're going to substitute in our 2 points. So I'm going to start off with P, and my first point is going to be x minus 3 squared plus y minus, let's look at my other point, it was y minus 6 squared, and that's going to be equal to r squared, which we're not sure of. I'm going to label this equation 1. Okay, so let's see what else we can do. We're going to have another point which we can substitute in. We're going to have x minus 7 squared plus y minus 2 squared, and that's going to give me r squared, and I'm going to label this equation 2. Okay guys, so what we have at the moment, we've got 2 equations, but we can see in our equations we've got 3 unknowns. So that means in order to solve for these 3 unknowns, we then need 3 equations. But we do have that other extra bit of information that tells us that the center passes through that line which they've given to us. So we're going to use that information to make a 3rd equation. This is how we're going to do that. So they told us that our equation is y is equal to x divided by 3 plus 1. So we're going to say y is equal to x over 3 plus 1. And guys, I really don't like working with fractions, so what I'm going to do is I'm going to multiply everything through by 3. We're going to have 3y is equal to x plus 3. Now we have our a and our b coordinates, which I'm then going to substitute into my 3rd equation. So we're going to have then that 3b is equal to x, which is now a plus 3, and I'm going to call this equation number 3. Okay guys, so what we have here, we've got all our 3 equations, we've got 3 unknowns, so what we've got to do is we've got to do a simultaneous equation that uses all 3 of these equations, and we've got to be careful with how we use, or we've got to be clever about how we use these 2 equations. My 3rd equation I'm going to try and leave for last, because that there gives us a relationship between our value a and our value b. The other 2 equations is our radii, which is helping us to find our equation for our circle. So what we're going to do, we're going to work with those 2 equations first. We're going to have then that equation 1 is going to be equal to equation number 2. So this is where the difficult part comes in, guys, and where the mistakes come in. We're going to equate these 2. So we're going to have x minus 3 squared plus y minus 6 squared is equal to x minus 7 squared plus y minus 2 squared. Okay, guys, so it's really crucial. When you get up to these points over here, you can see there's a lot of distribution that needs to happen. There are negatives that we have to take into account when we distribute and when we multiply things out. Guys, be very careful. Take your time in a test when you start doing these types of simultaneous equations, and hopefully you won't make silly mistakes and lose marks. Let's carry on with what we have to do. So when we expand this, we're going to have then, well actually I lie over here. You see I've already just made a little error over here because I'm using the incorrect equation over here. Well actually no, I lie. I'm using the correct one over here. But what I can do is I can substitute in my x with my a. Oh, sorry, but my x with my 3 and my a with, oh yo guys, I'm telling you, I'm just going to rewrite all of this again because I've made a little error. No worries, we can do this. What I've done over here is I've said a is equal to 3, where is supposed to be x is equal to 3. Okay guys, so forgive me for that. I'm going to quickly rewrite these equations and we're going to be back on track. Okay, so here we go. Let me try this again, guys. I'm going to have then x is going to be 3 minus a all squared. My y is going to be b. My y is going to be 6. It's going to be 3 minus a all squared plus 6 minus b all squared is equal to r squared. Again, that's going to be equation 1. And my second equation, I'm going to correct it. So it's going to be 7 minus a all squared plus 2 minus b all squared is equal to r squared. Okay, that's going to be equation 2. Okay guys, so a little mistake over there that I made. I have corrected it, and this is where you've got to be really careful when you do analytical geometry. These things can pop up. So let's carry on. We're going to equate equation 1 to equation 2. We're going to be then with 7 minus a all squared plus 2 minus b all squared, and that's going to be equal to 3 minus a all squared plus 6 minus b all squared. Okay, now if we multiply all of this out, guys, so I have done this in the past. So what I'm going to do is I'm just going to skip to that next step over there. We're going to end up with 9 minus 6a plus a squared plus 36 minus 12b plus b squared is equal to 49 minus 14a plus a squared plus 4 minus 4b, I'm running out of space over here, plus b squared. Okay, guys, so what happens over there, if you multiply those two equations out, that's the step that you're going to get to. Trust me on this. I'm just trying to save us a little bit of time because of that error that I made, but no worries. Okay, guys, what we can do now, from this point, we can see that b squared and b squared is going to cancel, a squared and a squared is going to cancel, and we're going to be left with the following. We're going to be left with 45 minus 6a, then we're going to have minus 12b, and that's going to be equal to 53 minus 14a minus 4b. Okay guys, so far so good. So at this point in time we can start collecting like terms, and that gives me negative 8 plus 8a minus 8b is equal to 0. Okay guys, so at this point over here we can see that we've got a and b in our equation. Now remember that third equation that I told you about? We're now going to bring that in so we can have an equation, or one equation with only one variable. So let's do that point next. So we're going to say then, we're going to go back up to the top of here and say that 3b is equal to a plus 3. So that's what we're going to substitute in here for a. So if we take this equation and rewrite it as a being the subject of the formula, we're going to have 3b minus 3 is equal to a. All right, now what we can do is we can now take this equation and substitute it in for my value of a. We're going to have negative 8 plus 8 multiplied by my value of a, which was 3b. Just want to make sure if it's negative or positive. It's negative 3, and that's going to be minus 8b is equal to 0. Okay guys, so at this point we can see now that my equation only has one variable, and we've got one equation, and that means we can solve for that specific variable. So if we have to do this, now our distribution, our multiplication becomes really crucial. We're going to have minus 8 plus 24b minus 24 minus 8b is equal to 0. Okay, you can see how crucial it is to get your signs correct. So from here, we can then simplify this. This is going to become negative 32 plus 16b, and that's going to be equal to 0. So if we have to solve for b, we're going to have negative 32 is equal to negative 16b. And if we divide both sides by negative 16, we're going to have that b is equal to 0. I lie. B is equal to 2. My bad. Okay, there we go. So we now have our value for b. To find our value for a, which is going to be the other coordinate for our center, we can be clever about this and just substitute it into one of the easier equations. So we're going to substitute it back into the equation with the straight line because they're nice numbers to work with. So if we do that part over there, we got my equation. 3b is equal to a plus 3. Remember that, guys? We're going to have 3b is equal to a plus 3, and my b is equal to 2. So we're going to have 3 multiplied by 2 is equal to a plus 3. And we can therefore say 6 minus 3 is going to be equal to a. Okay, guys, 6 minus 3, that's going to get me 3. And we can therefore say that a is equal to 3. Okay, guys, so at this point, we've got our center. We don't yet have our distance for our radius, but let's go have a look at our diagram and see how we can find our radius very quickly. Okay, so if we go back up to our diagram, we have that A was equal to, let's have a look over here, A was equal to 3 and B was equal to 2. Okay guys, so if we look at this diagram carefully, now remember I didn't draw this diagram to scale, but we can see that my y coordinates are exactly the same. So that means that Q would actually lie at some point over here. And that distance from my center to my point Q will be 4. So R is then going to be equal to 4. So finally we can write down my equation on my circle. We're going to have my equation on my circle being x minus 3 squared plus y minus 2 all squared. And that's going to give me my r squared. Remember, r squared is what comes over here, and that's going to be equal to 4 squared, and that's going to give me 16. All right. Okay, guys, so like I said, it was a monster of a question. You can see that you can make mistakes really easily, just like I did, but guys, be careful. Take your time in a test and exam, go and correct it. Right now, we're going to go to an ad break, and we're going to be right back answering more of your analytical geometry questions. Guys, stay tuned.